Okay, so let's break down further the classification of a mixture, the solution, which is a homogeneous mixture, and suspension and colloid, which are the heterogeneous. First, solution. It is formed when a solute is dissolved in a solvent. So when you are going to dissolve or mix one substance into another substance and it is thoroughly dissolved, forming a uniform in appearance, it is called a solution. When we say solute, it is a substance being dissolved, and a solvent, it is the substance that does the dissolving. Example is the salt and water. So, since salt is mixed and dissolved in water, it is called a solute. And the water which does the dissolving, it is called a solvent. Water is called the universal solvent. So, mixing salt in water, it is evenly mixed and dissolved, forming a uniform in nature. That is why it is called a solution. Uh, Solid component that dissolves in solvent is said to be soluble. So when a solid component is thoroughly dissolved in a solvent, it is called insoluble. On the other hand, if it doesn't dissolve, it is called insoluble. When liquid component mixes with solvent, it is said to be miscible, and if it doesn't mix, it is called immiscible. So there are different types of solution. So first, gas mixed with another gas. Example is the air is an example of gas solution. Gas mixed with liquid, forming liquid solution just like the carbon dioxide in the water or the soft drinks. Gas mixed in solid, forming solid solution, we have the helium in palladium. Liquid to another liquid, example is the ethanol in water. You can no longer identify saan doon ang ethanol sa water. Next, solid and liquid, forming liquid solution because solid components dissolve in the solvent. We have the salt in water, sugar in water. Next, solid mixed in another solid, forming solid solution. We have the steel, which is a combination of iron and carbon, and the brass, a combination of copper and tin. Now, there are factors that affect solubility of a substance. First, temperature. Of course, the higher the temperature, the higher is the rate of solubility, or it can be dissolved easily. Example, when you mix sugar in a hot water and mix it with a cold water, we can easily say that the sugar can easily be dissolved using a hot water compared to the cold water. Since temperature, the higher the temperature, the higher is the solubility. Next is the particle size. The greater the size, the lesser or the slower it dissolves, while the finer the particles, the faster or the higher rate of solubility. Another is the mixing. More mixing, faster mixing causes faster rate of solubility. And last, the nature of solvent or solute, meaning example of that is uh, oil and water. So oil, the nature of oil, it cannot be mixed or dissolved in water. Another is salt and sugar. When you mix them in water and alcohol, they dissolve faster in water. However, they don't easily get dissolved in using alcohol because that is their nature. So those are the factors that affect the solubility of a substance. The second type of mixture is a suspension, which is basically a heterogeneous mixture. So when we say suspension, it is when a solid does not dissolve in a liquid, and it is a mixture in which insoluble particles are suspended in a liquid or gas. So basically, we can easily identify a suspension because the particles or the components being added to the solvent or to the another substance are not dissolved. They can easily be seen. Example of that is the sand and water. So sand doesn't dissolve in water, they settle out. Okay? So it is a suspension. When a component settles out and floats up, meaning it is a suspension. And now we have the colloids. So colloids have the properties of both solutions and suspension. It is because colloids appear to be uniform in appearance. However, the particles or the components being mixed through other component, they are not totally dissolved. However, the particles are just dispersed or suspended on the medium, and they do not settle out because they are not heavy enough. So meaning, uh, para siyang solution because uniform in appearance, pero dili, it's because not totally dissolve ang kaniyang components. Rather, they are just suspended and dispersed on the medium. They cannot be separated by filtration. Example of colloids: milk, mayonnaise, deodorant, gelatin, whipped cream. So among the three, solution, suspension, and colloids, um, they are very common. Okay? Sila yung parati nating nakikita in our daily life. So, more examples of colloids. We have the body creams, the bread, the yogurt, the beer, toothpaste, milk, ice cream. So, kung titignan natin, mostly colloids, ang characteristics talaga ng colloids, mga malapot. Okay? Malapot sila because hindi nga na-dissolve yung components. Rather, they are just dispersed on the medium. Now, let's try to compare the properties of the solution, colloid, and suspension. So when it comes to the particle size, meaning the size of the components being added, the solution is less than 1 nanometer, colloid 1 to 100 nanometer, suspension more than 100 nanometer. Sa solution, less than 1 nanometer because they can be dissolved. Colloid 1 to 100 nanometer, they cannot be dissolved, and they cannot settle out. Rather, they disperse on the medium. Suspension, they are big enough, that's why they settle out. Appearance: solution clear, colloid cloudy, suspension cloudy. Separation: solution, they do not separate, as well as the colloid. However, suspension over time, it settles out or it separates. Filterability: solution, uh, it passes through the filter paper since the particles are dissolved. Colloid, as well as they pass through. And suspension, particles do not pass through filter because the particle size are big enough. Effect of beam light: in solution, light can pass through. Colloid, it scatters light. And suspension, light cannot pass through. Okay, and of course, the example, solution, best example is the salt and water. Colloid, the mayonnaise. The suspension, the muddy water. So, that's all for our mixture. I hope that you have gained an understanding, or you have uh, clear definition of what a mixture is and the differences among solution, colloid, and suspension. So that's all, and good day.